Students, today we have learned Introduction and Principle of IR Spectroscopy. Contains Introduction, Principle, Types of Vibrations, Hooke's Law, Factors affecting Vibrational Frequency. So we have firstly we have seen Introduction of IR Spectroscopy. The infrared absorption spectroscopy is concerned with the absorption of infrared radiation by a molecule and exhibits characteristic absorption spectra. The infrared region of the electromagnetic spectrum extends from the red end of visible spectrum to the microwave region of electromagnetic spectrum. The most useful range is between 4000 to 400 per centimeter. This region is often called the fundamental region from the standpoint of both application and instrumentation. The IR spectrum is usually subdivided into the spectrum of near infrared, middle infrared and far infrared region. Now we have seen principle of IR spectroscopy. In any molecule, it is known that atoms or groups of atoms are connected by bonds. These bonds are analogous to springs and not rigid in nature. Because of the continuous motion of the molecule, they maintain some vibrations with some frequency characteristic to every portion of the molecule. This is called the natural frequency of vibration. When energy in the form of infrared radiation is applied and when applied infrared frequency is equal to natural frequency of vibration. Absorption of infrared radiation means IR radiation takes place and a peak is observed. Every bond or portion of a molecule or functional group requires a different frequency for absorption. Hence, characteristic peak is observed for every functional group or part of the molecule. In other words, IR spectra is nothing but a fingerprint of a molecule. For example, IR spectra. We have seen IR spectra of ibuprofen. Now, we have seen criteria for a compound to absorb IR radiation. First criteria, change in dipole moment. Second criteria, applied IR frequency should be equal to the natural frequency of radiation. Otherwise, compounds do not give IR peak. Now, we have seen types of vibrations. First type is stretching of vibrations. These are vibrations in which the bond length is altered, that is increased or decreased. These are two subtypes. First, symmetrical stretching, in which two bonds increase or decrease in length symmetrically, and second, asymmetrical stretching, in which when one bond length increases, the other one decreases. Second type, bending vibration, in which in plane bending. In these vibrations, there is change in bond angle. Bending of bonds takes place within the same plane. Second type of bending vibration, scissoring, in which bond angle decreases. And third type of bending vibration is rocking, in which bond angle is maintained but both bonds moves within the plane. Next type of vibration is out of plane bending, means outside the plane of molecule, in which first subtype is wagging, in which both atoms move to one side of plane, and second subtype is twisting, in which one atom is above the plane and the other is below the plane. Now we have seen Hooke's law. We can see Hooke's law in action when we hang masses on the end of a spring. Each mass will apply a force that stretches the spring. Each time a 1 neutron force is applied, the spring will extend by the same amount. Now we have seen factors influencing vibrational frequency. From the discussion above, we know that the probable frequency of absorption can be calculated by the Hooke's law. However, it has been observed that the calculated value of frequency of absorption is not exactly equal to the experimental value. There are many factors which are responsible for shifts in vibrational frequencies, in which first factor is the frequency shift may occur due to the effect of molecule in the immediate neighborhoods of bond. Second factor, change in force constant of bond due to electronic structure. And third factor, due to different states of the same substance, for example solid, liquid or gas. Gas means vapor. The energy of vibration and thus the wavelength of its absorption peak are influenced by other vibrations in a molecule. The influence and extent of coupling of vibrations play significant role. Thank you.